Alright, hello. Here's a video for Unit 10, Day 1. And Unit 10 is all about exponents and radicals. It's not too bad of a unit if you kind of keep up with it day by day and make sure you're understanding as we go. So let's start with this reference sheet. It might be a purple paper that you have, but this will review some of the exponent rules that you might already remember. And there's some on here that you haven't heard before, so we're going to save those and do those some other time. Anyways, the first exponent rule, let's kind of do the example first. If I have x to the 6th times x to the 4th, what do you think that's going to equal? Well, think about what that really means. I've got 6 x's, 1, 2, 3, 4, 5, 6, and I have 4 x's, 1, 2, 3, 4. So really, how many have I got? I got 10. So this is the same as x to the 10th power. And by the way, all of these exponent rules you definitely did back in middle school, maybe Algebra 1. It was on your summer homework, so you've seen it this year a little bit, but this is where we're kind of talking about it specifically. So if you're just multiplying exponents with the same base, so when I talk about base, I'm talking about the x's, we keep the base, and what does it look like we did to the exponents? Right, we added them. So the rule in general, if I have x to the a times x to the b, that would be x to the, keep the base, add the exponents, a plus b power. All right, how about x cubed all raised to the 5th power? Okay, well, let's think about that. It's like I had x cubed 5 times. So 1, 2, 3, 4, 5. And if we use the rule we just did, these are all the same base and they're being multiplied. So we would keep the base and add the exponents. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So this is x to the 15th. But it looks a little bit annoying if we have to write it out like this every time. So what could I have really just done with the 3 and the 5? Well, adding 3 5 times is the same as multiplying. So the rule is when you have an exponent raised to another exponent, you multiply them. So this is x to the a times b power. Okay, well, this next one is kind of similar. Essentially, you're distributing the exponent into the other exponents, 3 times 5. So what do you think this is going to be? If you said xy to the 10th, you're almost right. But the one thing you got to watch out for is what if there's not an exponent listed? If this is just x, this really means x to what power? It's really like x to the 1st. So if I put the 5 through to both of those, that would look like x to the 5th, y to the 10th. So anytime there's multiple things being multiplied inside of a parenthesis, all raised to that exponent, you distribute them to both pieces. So this would be x to the a, y to the a. And you're going to see me a lot of times just write these ones in here so that I remember to distribute to those things that don't already have exponents on them. Now, this is a side note. What this is not is something like if I had x plus 2 squared, is that equal to, if this is 1 and this is 1, is that equal to x squared plus 2 squared? Or x squared plus 4? No, of course not. Why not? Well, what would you usually do if I were going to do x plus 2 all to the 2nd power? Right, you'd box it. So if there's an addition or subtraction inside, you're going to get that extra middle term. That addition and subtraction messes stuff up. This only works if you're being multiplying, or actually dividing works too inside, but not if it's added and subtracted. That kind of brings us to these last two. Remember what you do with x to the a divided by x to the b? Well, I like to think about it as canceling. So I have 5 x's on top. I have 3 x's on the bottom. What could I really do with those? Well, we could cancel 1x for 1x, another x for another x, another x for another x. What am I left with? We've just got x squared left. But what was the rule? If I'm dividing exponents with the same base, I would keep the base, and what did I do to the exponents? Well, again, this is what I'm thinking of, but what I really did is we subtracted them. So this is x to the a minus b power. Now sometimes that might end up with a negative number, and we'll see what happens in that case. So when we did this rule where I distributed the a through to both the multiplied pieces, you might have heard me say it only works if you're multiplied or divided inside. So by the same idea, this is also going to distribute. So what do you think x over y squared all raised to the third is? Again, if it helps you to write it out, think about what it means. It's x over y squared, and another x over y squared, and another x over y squared. So how many x's on top? 3, so x to the third. And how many y's on the bottom? 2, 4, 6. So y to the sixth. So you can see when you write it out, it makes sense, but what we're really doing, again, this is really like x to the first. I'm just distributing that 3 exponent and multiplying it to both the exponents inside. So in general, if I've got x over y all to the a power, we could say x to the a over y to the a. Now these other ones, you may or may not remember, x to the 0, x to the negative a. We're going to look at those more specifically in the notes today. So keep this to the side because I'm probably going to come back to that. You also might want to have these out just as a reminder when we're doing the notes. Okay, so if you can switch over to a piece of your own paper, I'm going to get a blank slate here. If you can get a piece of paper out as well, that would be wonderful. If you need a moment, pause the video. But when you got your paper, you can label this the start of Unit 10. And Unit 10 is practice with exponent rules. I guess this is technically the lesson. Unit 10, Day 1 is practice with exponent rules. Unit 10 is exponents and radicals. All right, so for the next couple days, you're going to see these types of directions. It's going to say, write each expression with only positive exponents. In simplest form. That means if you can reduce, we got to reduce. And I got a bunch of different examples. Some of them are a little bit easier, some of them a little bit harder. But we'll just start with an easy one. X to the 10th times x to the third. Think about it for a second. What do you think that would be? Well, this is pretty much a straight application of that first rule. I'm going to keep the base and add the exponent. I've got 10 x's, and now I've got 3 more. So this is x to the 13th. Part B. Let's do 5x to the 4th times 6x cubed. Kind of the same idea. What do you think you're going to do with the 5 and the 6? What does it look like they're doing? Of course, they're multiplying. So this is 30. 30x to the 7th. There we go. Or C. What if I had x cubed, y squared, x to the 6th, y to the n? Now you probably know that it doesn't really matter what order things are in. Essentially, I have how many x's here? They're all multiplied, so there's 3 here, 6 here, so I'm going to get x to the 9th for sure. What do you think the exponent on the y is going to be? Well, again, if we're multiplying, what do we do to those exponents? Hopefully you didn't say y to the 2n because we add the exponents, just like 3 plus 6. So it's got to be y to the 2 plus n. There you go. Example D. Let's do a division one. 6x to the 10th divided by 12x to the 4th. So remember the directions. Write each expression with only positive exponents. So I haven't had any negative exponents yet in simplest form. So you can think about subtracting, but again, I like to say, okay, there were 4 x's down here. All those are going to be gone. I'm going to have how many left on top? Well, if I were to write it out, I'd cancel out 4 of them, so there's 6 left. And then we can also cancel the numbers. You know from the last unit, if I'm multiplying, I'm allowed to cancel. So I could take a 6 out of here, and I'm left with a 1. I can write it, but I don't need to. And if I take a 6 out of here, I'm left with a 2. So we're left with x to the 6th on top with a 2 on the bottom. So x to the 6th over 2. Now just as a side note, if this was multiple choice, I hope you know that that's the same as 1/2 x to the 6th. If you see 1/2 out front being multiplied by a variable, you can always multiply that to the top, because this is like x to the 6th over 1. Part E, x to the 6th, y to the 3rd, all over xy squared. Think about it for a second. What do you think it's going to be? Did you say x to the 5th y? You're soup smart if you did. 2 y's go away, leaving 1 on top. This 1x is going to cancel, leaving 5 on top. So x to the 5th, you could write y to the 1st, or you could just write y. All right, so everything we've done so far pretty much follows some of those rules that we've been writing. But what about x squared over x to the 5th? Well, we can kind of think of it 2 ways. If we use the subtraction rule with division, I keep the base, subtract the exponents. We always do top minus bottom, 2 minus 5. So 2 minus 5 is -3. So this is x to the -3rd. Okay, we just used our rule. Now the directions did say only positive exponents. There's my first negative exponent, so we'd have to worry about how to deal with that. But how else could I deal with it? Well, we could also think of canceling. If I had 2 x's on top and 5 on the bottom, and if I start canceling out, this x goes away with this x goes away with this x. Uh-oh, there's no x's left. So I've got 3 x's on the bottom, x cubed. That's a 3. Let's try that again. 3 x's on the bottom, so x to the 3rd. Looks better. What do you think should be on top? We can't say 0, because think about what happens. If I have a number divided by a number, like 5 divided by 5, or 8 divided by 8, or whatever, x divided by x, what am I going to get? 1. So 1 over x to the 3rd. Now both of these are correct answers. So if they're both correct answers, what's that mean? They must be equal. So this is a big rule in general. X to the -n is equal to 1 over x to the n. And you can see how that rule follows here. If I have a negative exponent, it basically flips to the bottom. So we'll write that in on our purple sheet in a minute, but for now, just keep that in mind. But it would also work if the negative exponent was on the bottom. So what I want you to really think of with negative exponents, negative exponent means flip the side of the fraction it's on. So if it was on top, like it kind of is here, because there is no bottom, it flips to the bottom. But if the negative was on the bottom for some case, it would flip up to the top. Okay, so we'll come back to that. You'll see that a lot. I think we're down to G, example G. The other rule I wanted to review today comes up here. If I had x to the third divided by x to the third, well, for the same as last time, I could use the division rule. So this should equal x to the 3 minus 3, which is obviously x to the 0. Or if I did my cancel rule, we've got our 3x's on top, we've got our 3x's on bottom. They're all going to cancel out. What am I left with? Again, if you're dividing something by itself, you're always left with 1, not 0. So, since these are both legitimate ways to solve this, what does that mean? It means x to the 0 equals 1. So I'm going to say, in general, because this is a rule, anything raised to the 0 power is always equal to 1. Now when I say anything, I really mean anything. It can be multiple terms all raised to the 0 power also. If it's everything's being raised to the 0 power, it's definitely 1. For example, if I had 3x all raised to the 0 power, what do you think it is? What did I just tell you? It's 1. Because everything inside is being raised to the 0 power. But let me caution you, this is different than 3x to the 0 with no parentheses. What do you think that's equal to? It's actually equal to 3, because what exponent is on this 3? There's none listed, so this means 3 to the first. So this really means 3 times x to the 0, which is 1. That's 3, not 1. So watch out for that little subtlety, because that does trip people up sometimes. Okay. You might still have room. If you still have room, just keep writing on your paper. I'm going to flip to a new page because I got a few more examples to do still. Here is example J. Let's do 2x squared, all that cubed. Think about what you think that would be. Did you say 2x to the 6th? I hope not, because that's wrong. Remember, this 2 has a 1 on it again, so this 3 gets distributed to both pieces. And it's not 2 times 3, so it's not going to be 6 out front. It's the exponents that get multiplied, 1 times 3. So this is going to be 2 to the 3rd, x to the 6th. 2 to the 3rd is 2 times 2 times 2, 8. So it'll be 8x to the 6th. So I would always fill in 1s where there's missing exponents, if there are any. That'll help you. About 3 over x squared, all squared. Think about that one for a second. Well, if you're thinking the same as last time, I would put that 1 here, and the exponent's going to go to both pieces. So that's 3 squared over x to the 4th, so 9 over x to the 4th. All right, and then let's get a little tricky with these last couple here. Let's try negative 2x squared z to the 5th all over 3z to the 3rd. But then all that cubed. Okay, so those ones we were getting into at the beginning were kind of just getting our feet wet. This is like a Regent style question. So the first thing I would tell you to do is put 1s wherever there aren't exponents. This is really 2 to the 1st, and that's really 3 to the 1st. Now you could do some canceling with the z's in here, but as a general rule, I always say distribute exponents first. So this 3 is distributing to every exponent, not the numbers, the exponents. So I'm going to write this as negative 2 to the third. Now I put that in parentheses because the negative is still being raised to the third power also. Then it would be x to the 6th, z to the 15th, all over, not 9, but 3 to the third, z to the 9th. So keep in mind, again, it's the exponents that get multiplied, not the actual bases, the numbers. Okay? So now let's evaluate this. What's negative 2 to the third? Negative 2 times negative 2 is 4, times negative 2 again, that's going to be negative 8. X to the 6th, z to the 15th. And what's 3 cubed? Don't say 9. It's 27, z to the 9th. Anything else? Cancel those z's. We got 9 of them on the bottom. Those are all going to cancel out. How many will be left on top? 6. So negative 8, x to the 6th, z to the 6th, all over 27. Okay, so that's definitely a little trickier, but if you keep my order in mind, distribute the exponent, evaluate, cancel, simplify, you'll have better luck. All right, one more little example, then I got 2 kind of word problems, if you want to call them that. Let's try a to the negative third, a to the 6th, all over 3a to the negative 9th. Okay. Now this one's got negative exponents. And there's different ways to approach it, but again, I would say distribute any exponent that needs to be distributed first. In this case, there's no exponent on the outside here though, so nothing's being distributed. And the next thing I would always say, it hasn't come up yet, is deal with negative exponents. Now you might remember from previous example, x to the negative n is 1 over x to the n. But what I really want you to focus on is that negative exponent means flip the side of the fraction it's on. Okay, so what I would suggest you do, and you're going to see me do this a lot more tomorrow also, is circle anything that has a negative exponent. So a to the negative third, a to the negative 9th. Now notice I didn't circle the 3 on the bottom because what exponent does that have? And that has a 1, 3 to the first. So that doesn't get circled. But the reason I circle anything with a negative exponents is because what a negative exponent really means is we flip the side of the fraction it's on. So now on top, the a to the 9th is up there. And the bottom, the a to the third moved down there. I literally just flipped the side. Everything that's not circled stays where it was. So that's still a to the 6th, and this is still 3, or 3 to the first if you want to think of it that way. So then what's on top really? A to the 15th over, and I'm just going to write the 3 first, 3a to the third. And then what do you think my last step is going to be? Cancel. 3a's go, there's still 12 of them on top. So a to the 12th over 3 is the answer. Now, I'm sure there's other ways to do that. Some of you might have thought, well, why don't I add these together and make this a to the third up top to begin with? You can definitely do that. But if you follow this step of circling the negative exponents, dealing with those first, it'll make all the problems, especially the trickier ones, that much easier. Okay? Any questions? If you had anything that didn't make sense, star them so that I can answer them for you later. I said there'd be 2 kind of wordy problems, and then we'll be done. So here's example 2. Rewrite the following in the form kx to the n. And evaluate for the given value of x. And I'm going to start you with 2x cubed times 5/4 x to the negative first. Okay. So I know I just told you always circle stuff with negative exponents and flip the side of the fraction it's on, but don't forget those other rules because I could do that here, but I could also just add these two exponents together. So this is a big expression that's being multiplied. The numbers are being multiplied, so 2 times 4/5. If you need your calculator for that, that's fine. 2, oops, I'm turning on. 2 times, I say 4/5, 5/4 is what it really is. And it's 2.5, but let's keep it a fraction. 5/2. So 5/2. And if I just add these exponents, because we're multiplying x's and they have the same base, so if I add the exponents, this is going to be x to the second. So I've already done the first part. We write the following in the form kx to the n. 5/2 is k, n is 2, 5/2 x squared. It also says evaluate it for the given value of x. Well, I guess you can't do that because I didn't write it. I should have also said here x is 2. So if I want to evaluate that, all I got to do is plug that in. So it's 5/2 times 2 squared. Can you do it in your head? It's going to be 10 because that 2 cancels with one of these and you get 10. If that doesn't make sense, just plug it into your calculator. Okay, last example for today. Last example. If x equals 5a to the fourth, and a equals 2b to the negative third, express x in terms of b using only positive exponents. All right, so when it says express x in terms of b, that means you should have x equals in the end, and your answer is going to have b's in it. It also wants only positive exponents, so we might have to deal with something with that. Okay, so x in terms of b. Well, if x equals 5a to the fourth, and a is 2b to the negative third, I can plug that in for the a. So this is going to be 5 times 2b to the negative third. Then what's still on the outside? This 4 is still here. Okay, so it says express x in terms of b. So x equals, we got b's in our answer, that's good, but only using positive exponents. Okay, so we got to deal with this. And to get into there, I got to deal with this 4 out here. What's this happening with this 4? It's being distributed. It's both things inside of here. Remember, what's 2 have on it? It's 2 to the first. So put that 4 exponent through to both of those. So the 5 is still out front. And now if I distribute that, it's going to be 2 to the fourth, b to the negative 12th. And we multiply the exponents. What is 2 to the fourth? 16, b to the negative 12th. 5 times 16, well, that's 80, if you didn't know. 80b to the negative 12th. But I still don't want that negative exponent, so I would circle the thing with the negative exponent, not the 80, because that's like 80 to the first. And end up with 80 on top, and what on the bottom? B to the positive 12th. Remember, when you circle a negative exponent, you flip the side of the fraction it's on. This one didn't have a bottom, so it was on top. Now it got flipped to the bottom. Okay? All right, so that's the end of your own notes. Let's flip back to that reference sheet and fill in the two things we can fill in. So we've got all those rules. Anything raised to the 0 power, what's that always equal? 1. So even if it's 5x, as long as it's all raised to the 0, it's equal to 1. And remember, x to a negative exponent, if it's on top, it becomes 1 over x to the positive exponent. So write a little note. Negative exponent means flip. Flip the side of the fraction it's on. So if I've got 2 to the negative third, if I follow my circle rule, I would circle that. There's no bottom, so that means it's on top, so it needs to go on the bottom. It'd be 1 over 2 to the third. And since this one's a number, I can evaluate that. 2 to the negative third is 1 over 8, because 2 cubed is 8. Okay. All right. You'll notice there's one more section on this reference sheet that I haven't filled in yet. Fractional exponents. That'll come later this unit. But you're now ready to do this homework and follow the rules that I did. So make sure you distribute, circle negative exponents, flip the side of the fraction it's on, distribute those exponents. Don't forget these 2's and 5's, or 2 to the first, 5 to the first. So do the best you can with those and be really diligent in checking your answers so that you know that you either know it or you got some questions for me. Good luck.